Hello, everybody can see my screen. All right. So
Yes,
now
sir.
we finally made it to ROS2. Congratulations to everybody that made it. We are exactly at the midpoint of the training. I mean, roughly, and everything is going as intended so far. I've had like a few people have a couple of issues, but so far so good. Now, before I talk about ROS, before we start properly, so many people asked me on my DMs if like they probably want to focus on robotics and they don't know if they should focus more on the theory or if they should learn ROS. Like they should focus more on ROS and learn ROS. And if you are on the call now, pay attention. If you are not on the call, I just hope the person will watch the recording. But either ways, I will explain from my own point of view. I am in November when I started last year, I also had that issue, right? But there's something you need to know. There is only finite time, and then there is an infinite amount of knowledge. And then if you now say you want to learn robotics theory, how much of that theory do you think you can cover? How much do you think you can learn? Can you use everything? Or can you learn everything? And if you say you want to focus on ROS, understand that ROS is just a tool. An example that a lot of people would relate to is, I mean, most of us here, yeah, I started last year. I was documenting my journey on LinkedIn. I look at the first post I made on LinkedIn and I laugh at myself like, I was so dumb. Either ways, um, what was I saying? Okay, we're talking about ROS. Good. So, for the people that, did engineering, most of us were engineering students. At least we did CAD, where you do SolidWorks and the rest. If, for example, you were asked to design a V8 engine in SolidWorks, understand that if you do not have the background of an engineer, you would not know what component even fits in an engine. You won't know what a cylinder is. You won't know what nothing is. You could know how to use CAD and not have the background of an engineer. In other words, CAD is just a tool. SolidWorks is just a tool. What really makes people good at it is because they actually know the background of these things. Now, what am I trying to say? ROS is just a tool. And my own journey, I started ROS in November. I learned ROS for like 3 days and I gave up on it. I gave up on it. Reason being that if you start with ROS, except you are not the type of person that loves to understand things like intricately, if you start with ROS, you quickly realize that it seems they are following a pre-built setup. Like we'll talk about nodes. One node connects to another node. One node does this. One node sends topic here. Everything looks pre-built. And then you start to question, why is it that way? Why not the other way? Now, if you actually learn a good amount of the theory, when you move to ROS, you would actually understand what exactly these things are. In my own case, from November when I stopped writing ROS, there is no post, or like there is, because the way I did it, anything I learned for the day, I always make post on LinkedIn. There is no post whatsoever about ROS until the third week of January 2024. And during that gap, I did other things. Robotics theory. I actually had to understand what robotics is and everything. And then when I came back to ROS, things looked far easier than when I started it. And then we stayed for like I did played with ROS for like 2 more weeks, and then I left it again because I want to really understand what I am doing. And the last time I picked up ROS was some days ago because I want to do this, and then maybe some other gigs that I've gotten. So yeah, it's the same thing. What ROS is just a framework for people that do web dev. If you already know vanilla JS, you understand how JavaScript work and how the whole web dev thing flows. It's not difficult to learn a new framework. I mean, excluding the overhead of learning a new framework, it's pretty much straightforward. So that being said, um, let's get into what we're supposed to do today. Okay, so the rules so far, everybody follows all these rules. I really appreciate you guys for that. I don't have to scream, mute your mic. I appreciate the level of civilization I've seen so far. All right, so everybody still familiar with this? Okay, now I decided to start with this meme. Why did I decide to start with this meme? I love this meme so much because everything looks pretty straightforward in robotics until you get to ROS. Like everything looks so straightforward and simple. Yeah, like ROS is this mess, like this whole lot of mess, and we're going to see why. Now let's start with what exactly is ROS, Robot Operating System. See, when you define something, like there is problem when a term is used in the name, but it doesn't mean that term. So a lot of people are like robot operating system, and they think ROS is an operating system. That's one of the problematic sides of ROS. To begin with, it's not an operating system. For the reasons best known to Willow Garage, they decided to name it robotic or robot operating system. Now, it's not an OS. If you ever want to run ROS, like an operating system is something that will be able to run on a like bare metal, something like this, Raspberry Pi or whatever. That's an operating system. So if you now decide to use ROS, you find that you have to be running Linux, any flavor of Linux, at least that has ROS support, before you now install ROS or anything on it. So it's not an operating system. These are the good perks of ROS. It's good for performance, reliability, real-time robotics. Real-time robotics, I mean, I think we all know what real-time is. To be able to maybe send data and, if not visualize it, use it in real time. So that is what I mean by real time. All right. Then we have what is called a middleware. Now, I will not go deep into this because this has to do with like ROS structures, where we have the different stacks. But let's leave that for something for another time. But it's like a middleware that helps robots talk and communicate. It provides communication. Now, there are key things in ROS too: nodes, topics, services, actions. We'll explain all these things. The only problem with ROS is there are so many terminologies that you need to really understand to know what you're doing. Now, ROS also has tools for simulation. We saw Gazebo, NVIDIA, Isaac Sim, Mojoko. There are a lot of them. Gazebo is closely tied to ROS because of this ROS-Gazebo bridge. Like they have like strong development, so it's easy to integrate ROS with Gazebo. It's also easy to integrate ROS with NVIDIA Isaac Sim. And then the rest, you just need documentations. Now we have visualization. For those of us that know RVs 2. Some of us launched it, some of us has not yet launched it. But if you installed ROS, you have RVs. And if you have not installed ROS, don't worry. Just try and follow and understand what's going on. And then for debugging, we have so many ways to debug. We might look at some of them few minutes from now. And then this is the key of ROS standardization, such that I can do something and I can easily ship it to someone at the other end of the world and he can run it on his side, right? I think that's one of the issues that was there before Java was created, because Java comes with its own virtual machine so that you can run it anywhere. Think of it like, okay, yeah, that's how ROS kind of also functions, but there is no virtual machine, just like I'm just making a reference. All right, so are there reward applications of ROS? Yes, they are. There are a lot of reward applications of ROS. The ones I've worked with, particularly Blue RV, you can integrate ROS with it. I think it's either Franca or UR. Okay, yeah, it's URE5. We've also worked with that. Autonomous labs. This is this was done with Isaac Sim, but like not in I didn't have access to the robots, but like Isaac Sim simulations. But like ROS has reward applications. I think there is even a golf trolley. There is a golf trolley. Let me just drop it in the chat. For those that want to read, golf trolley by Robotics. It's an application of ROS. I think they raised if I remember the correct figure, about 700,000 euros in funding. That was one of the like massive things that happened in Belgium last year. Yeah, that happened in Belgium last year, so it was pretty nice. All right. It is normal culture to compare normal ROS to ROS2. What I mean by normal ROS, or no, let me not say normal ROS. The old ROS. There's ROS1, there's ROS2. ROS didn't start as ROS2, right? It started completely different as ROS. And then there were some issues they ran into that made them like modernize it into ROS2. And ROS2 has been around since like 2010, if I can remember, or maybe 2010, 2018. But it's not like, no, it's 2010. It's not like it has been, it's not like it's new, right? It's this kind of thing where you introduce something, but people are already used to the old one, which is ROS. And then it takes like a long time for it. So like ROS2 like blew up a couple of years back, right? With ROS Iron, ROS Foxy, yeah, that's another version of ROS. So everything on this particular slide, you will not relate to it directly unless you've used ROS before, and there is no need to go and learn ROS because you want to relate to this. So just know that I'm sure we know there is Python 2 and there's Python 3. Most of the Pythons we install now, we see Python 3.11, 3.12. There's Python 3. It's like the modern form of Python. A lot of things have been. I saw somebody that wrote the last tax with one of the most recent most recent features of Python. And I think I started that. I was like, I was going to reach out. I wanted to know if I couldn't tell if it was completely ChatGPT or if the guy actually understood, but it was impressive. Python naturally does not have type checking, but somehow there's a way to like enforce it. So that's kind of stood out, and I'll reach out to the person. But that's just by the way. In case you are the person and you are aware of what you did, you can also still reach out to me. Now, ROS is not real time. It's difficult to get like real time robotics in ROS, but you can get real time in ROS2. Single host. Now there's single host, multiple machine. Things like this demand some form of depth in computing or computer architecture to understand, because the way ROS kinds of work is it's kinds of like connect different parts together. I think one thing I can do is I can skip to the next slides. We brush up a bit about more things about ROS. I probably will come back here so you maybe understand it more. Emmanuel, that was you. That was you. All right. Noted. We'll go talk for DM. Okay. Now these are things we need to know first, right? It's not as if we need to like store them all in our head. Let's just know that, okay, there's what is called a node, there's a topic, there's a message, there is service action parameter. And as we go on, we'll like build on top of that. So a node is like an executable. Wait, there's a more detailed slide on that. Let's come here. Good. Basically, let's use something as an example. We can say a car, an autonomous vehicle. It has, let's not use like the big cars with all of that, like a small one that uses motor, right? So we have the motors, we have the tires, the wheels. We also want to give it eyes, so we give it like a camera and also a lidar. So we have camera, lidar, and we have motor. So what we will do is we want to be able to take pictures to see the surrounding. If you notice, that is like a small task just to take pictures. So what you do is you write a node for it. So that node, anytime you run it, depending on how you write it, the idea is to take pictures for you, right? Then you also want, let's say, if the car sees an object, it should slow down, right? So now you need the camera to take pictures and probably like compare to see that, okay, when there is something there, some form of computer vision, right? And then when it sees something, you want the car to slow down, meaning you want the motor to either stop spinning or like spin the opposite way to like counter the forward motion. Good. Now what you're going to do is you are going to have nodes for the motor and nodes for the camera, right? And then the camera, it's going to like be sending messages to the nodes for the motors. How this message is being sent, we'll go over it. But for now, understand that for every feature you try to think of, any feature you want to add, you are most likely either creating a new node or you are writing to an existing node, like modifying the node to do something. These are just building blocks. We'll see like a clear example very soon, but just try and stick with me. So basically, a node is just a small program that does one job inside your robots. One job. Every sensor, motor controller, AI module, it runs as its own nodes. So the AI module in this case, your computer vision, right? There are ways where you just write you write everything in one single node. Again, everything is up to like your programming architecture, the way you do things, but you can easily still split them and you have no issues. Now, examples are this camera node. Now the arm planner, we all did that. We did that. We saw when we did the 2D arm, when we did the 3D arm, right? We're going to go into that at the end of this, because probably we'll just show the demo about how things shake out with that, right? But I'm not going to explain much. Now there's a path planner. Path planner is a bit more complicated. There are some classes where I explain path planning, where I talked about forward kinematics. Forward kinematics is setting your joints and then knowing where to get you, And then path planning is for navigation, it's knowing where you want to go to and then figuring out how to get there or where to go to get there, right? So all these are like surface, but it helps you get the idea of things. Now the next thing is the topic. Remember I said that for the car to slow down, the camera has to somehow send messages or has to send signals. Something has to be sent from the camera to the motor to tell it, okay, I think you need to slow down now. I am seeing something. That communication is done with topic. A topic is a communication channel where the node sends or receives data. So we could have a topic called images, and the camera would constantly take pictures and send to that topic. It publishes to the topic. That's the right word. Nodes that publish to the topic. And then the motors can subscribe and like listen to it. So this is something that was not really in the first ROS, right? Because what this allows is we can say, okay, instead of let's increase the system, right? Instead of just the camera, we have the camera and a lidar. And lidars are good at estimating distance from obstacle, right? The camera just like sees the obstacle, and you can use some computer vision to like estimate distance, but it's not always the best. Lidars are good at that. So now we have a lidar and we have a camera, and we want the motor, right, to know the distance from the object. But we want to do it in a nice way. Like, since we already have a camera and then we have a lidar, we can use computer vision to estimate distance. We can also use the lidar to directly estimate distance. So let's do it this way. Let's provide the motor with these two distances for whatever reason you want to do that. What you do is you will just have a single topic called distance, and then you can publish from your two sensors, your camera and your lidar. And then if you have more components that want to subscribe from that topic, maybe you have your motor, you have maybe some other components that you would love to know about the distance, then you can subscribe to that distance topic. So like 1 million things can publish to the topic, 1 million things can subscribe from the topic. That way you don't need to send, the motor does not need to, the camera does not need to send directly to the motor and then send to the other person. It's just sending once, and whoever likes what is there will just take from it. Contribution, alternatively, consider an automobile production line, welding. Yes, that can be seen as that can be seen as nodes. Yes, but in this case now, it is a more abstract form of reasoning. It's a more abstract form of reasoning because yeah, the welding section is a node, the painting section is a node. Yeah, but I mean that works too if anybody understands it that way. But I'm trying to give like a direct explanation with a well-known robotic system. All right. The next thing we have messages. Now I said we are sending something, right? We are sending data from. You notice how everything we're about to explain is just for communication, just for sending things around. We are sending data from camera to motor. Now, in the course of doing that, we've explained what nodes are. There's going to be a node for the camera, there's going to be a node for the motor. In the course of doing that, we've explained what topics are. The camera doesn't send directly to the motor, it sends to the topic. Then the motor like gets from the topic. We've also now come to messages. Messages is that actual thing that is being sent. What exactly are we sending? Are we sending a text? Are we sending a number? Think of it as data types. I think TC talked about variables. And it was like, the variables are just like containers, right? Containers of certain types. So think of it as, what exactly is inside? This is done so that there's going to be a structure. So that your motor will not say he was expecting camera and what he got was LiDAR. Everything has to be strictly, like the type has to be properly checked. Because you don't want to start debugging what data type is being sent, or like, I don't know if you understand. It makes everything easier. So this is just like the data type of the variables. Now, standard messages, string. Standard messages, floats. Those are like standard messages for us. And then they have sensor messages, image, laser scan. This is for LiDAR. This is for camera. There are a lot of them. As a matter of fact, you can even create your own type of message. You have a custom robot. This has not been done anywhere before. You want to, the type of message you want is so and so, and no existing ROS message does that. Feel free, you create your own message. That's one of the good things about ROS. All right, now we have services. Now, for the nodes, you realize the node, the camera is just sending pictures. It's not getting anything back. It doesn't even want to get anything back, right? The camera is just sending pictures. The motor is just accepting pictures or accepting distances. Finish. That's a one-way communication, at least from the camera side. No feedback is going back to the camera, nothing. So now, what about we want feedback? We want feedback. Say, go to the door, and then when you get to the door, I have another instruction I want to send to you, right? You use like a service. You tell it what to do. If it's done, it does it. It gives you feedback that, hey, I'm done. If it's failed, it gives you feedback. For some reasons, I have failed. So that's the idea of service. Now, this looks a bit far stretched because now we are going back and forth. You want to know if something has happened so that you can get the next thing that you want to do. That's it. Now, one node can still talk and wait for another node. This is just how services work. And then the more
It's just a moment before you move on. Can you hear me?
Yeah, I can hear you. What's up?
Can you just go over that's the last point is called service. I did not really get that service. Like,
okay. Okay. So slowly we're moving into some confusing concepts. Services like okay, let me give you this example. Still with our car. The idea is, now this is our mission with this our autonomous vessel, with this our autonomous vehicle. Let's go to a marked position X and then take a picture of that position, right? Maybe there's an art piece that's at that position that I want to take a picture of. So what's going to happen is there is another form of data type or concept of ROS that allows us to get to the point. But let's say we've gotten to the point. Where services come in now is at that point, after you take the picture, right? Service would like, you can use a service to say, okay, after taking this picture, or take the picture. If you are done taking the picture, we'll save that picture and then I'll give you the next thing to do. That's more like how service works. It basically sends a one-time request and waits. Now, in the logic of your service, right? Let's assume you get a failed like camera refused to take the picture, you might now have like a fail-safe mechanism or like a recovery mechanism. Maybe you might now say, okay, turn off and turn on the camera, a whole procedure. But that's the idea of the service. It has to be triggered by the response of the request it sent out. I don't know if you understand. Queen? Okay.
Yeah, I guess when we talk about how I understand it, I understand it was flexible. Thank you.
Okay, all right. Okay, so for actions now, think actions is, okay, put it this way. Action is a type of service that gets feedback at predefined times. Like, you know, in the previous example, I said we want to drive to a point X. We want to get to that point to take a picture. The process of driving to that point X will be done with an action. What would the action do? The action will tell the wheels, okay, drive to this point. Now, as you're driving to this point, be sending me feedback. The feedback can be how far are we from that point. Every 10 seconds, be sending me feedback. Whatever the action wishes to do with the feedback is fine. Most times, we just use it to do control systems, which we might probably see later on. But just understand that once we now get to the point, then it sends the final feedback that we are here, and then the action can now rest. So this is how different forms of or different concepts, different systems or like subunits of ROS works. And over time, you probably have to like watch different explanations, or because different people have different ways they put it, but in implementation is the same thing. An example that's for people that order things online, order food, order pizza, you are going to be getting regular updates. They just start cooking it, it's baking, it's on the way, it's at your doorstep, you get regular updates. And then when it's finally delivered, that's the last update you get, the action stops. So this is just something you need to just know that, okay, yeah, something like that actually exists. Here, what they said, it is great for navigation. Go to point X. It's going to continue running until that point is met, or until there is like an issue, and then you trigger a fail safe. So, parameters. There's a lot of editing that goes on in ROS, and this is general computing knowledge. You do not hard code parameters like API keys. You don't hard code it inside the code base, right? You should have like a file that most likely will not be exposed. So just same thing for your parameter files. Everything, all the variables that you know might change, you keep them in a parameters, like parameters file. And then your node just reads from that parameters, right? You can also store variables from the nodes into the parameter file. Just know that these files do not change the code, but they control certain behaviors. You can tune the behaviors easily rather than going into the code to always look for things to tune. So this is like not much, you don't need to spend much time here because like it's basic. All right, now, sorry, there's a bit of a lag. Okay, parameters. Aha, now if we come back to this, now that I've gone through a lot of things, the node is the small executable. Now you know that, okay, camera reader and controller, anything you want to do, any small feature is a node. I think probably now the picture might be clearer. A topic is a message highway between nodes. A topic is the channel where you want to send to different components. You send to that topic. You don't send directly to those components. The service, the message is the package of the data, the actual thing that is being sent on that topic. Request, this is service. request stroke response. At least now you know what request stroke response is. You send a request, you chill, the response come back, you act on that response. Action is long running tasks, and then parameters, runtime configurable files. You can just configure them before you run. So I think that's why I had to like explain this first before going back. Makes more sense that way. Okay, this is how it's going to work. If you can run this as we move on, like it's encourageable, but I would not advise you to keep your head buried in running it and missing out on the explanations. I mean, you can always watch the recording though. If that is fine by you, it's okay. Because I'm going to be running it on my side, and it should also run on yours, hopefully. So don't stress yourself about where did this code come from. Where did this? It's somehow the knowledge builds on itself. You just learn it a bit, and then it builds on that. Abstraction keeps our brain safe while we are thinking of huge tasks. So, do you have anything? The slides are not on GitHub yet. You want to be using the slides like in parallel with the class. Does that help you? Should I send the slide on the book? I mean, it's not on the GitHub yet, but I just finished the slide. That's why it's not. That's why it's not on the GitHub. Okay. I mean, so I think I'll just drop it. 1 minute. Let me drop it on the. Okay. I would have it on the GitHub later. I just don't want to start pushing and sending you to the GitHub. So. All right. Where were we? Great. So. What were we doing? All right. Now we're talking about this line of command. And let me explain what happens before I run it and what to expect. ROS run, the first thing you can see is ROS2. Let me go back to this. The first thing you see is ROS2. And by now, we should have known that if we're running any command, cd, change directory, mkdir, make directory, git clone, the git first. You have to say what you are doing. So it's no surprise that we have ROS2 first. So ROS2 run simply means run a node from a package. So the next thing that usually follow is the package and the node. Now, to make things organized, since I said we can have so many nodes depending on what we want to do, you can group these nodes into packages. So most times, if you want to run a node, you run the node, you need to call the package, and then, hey, this is the node I want to run from this package. And whatever happens, happens. Whatever you've told the node to do. So in this case, I would run it, and we would see what this do. And I'll explain what it does, what you do. So I'm going to go to terminal. and I'll make the terminal super big. Okay, thank you very much for that reply. Okay, so we have sorry, this is something else. Okay. Okay, so I think this is less distracting. I have a lot of my things out of the way now. So what we're supposed to run was ROS2 run demo talker. Hold on. What are we supposed to run? To run, yeah, demo node CPP. ROS2 run demo node CPP talker. And all we see is it's just publishing hello world 1, hello world 2, hello world 3, hello world. It just keeps on publishing it every single second. Now, what is really going on? This script is just a sample script to tell you how publishing actually works. This thing it's publishing could be anything. It could be pictures, it could be motor control, it could be anything at all, depending on the message type that you specify. But right now we're publishing strings. We're publishing strings, hello world 1, hello world 2, and the strings is incrementing every 1 minute. This to show you that I can keep on publishing anything. This is the node talker. This is the timestamp. This long stop, it's a timestamp. So if you look at it, the difference between up here and the second one is roughly 1 second. So this is going to continue running. Now, what exactly is happening? When we do ROS2 run, we run a node that lives in a package. Talker is the node, and what Talker does, it does this. The package is demo node CPP. So demo node CPP is the package name. Talker is the node. This starts. We'll come back to this. We'll come back to this. You can see we've introduced something. Chatter. If you are following the slide, you see chatter. Don't worry, we'll come back to it. Now, in order to show you what it looks like to subscribe, right? What it looks like to subscribe. This is the one publishing, meaning this could be the camera. So let's look at, okay, what about the motor? How does it look like to take in data? And this is what we will do. We'll open another terminal. What I detach this? Okay, we'll open another terminal. Let me also.
Sorry, I have a question.
Yeah, what's up?
So right now this demo talker node is publishing, right? So
Yeah.
where is it publishing to? How do you know where it's publishing to from the terminal? I know you can use I think RKT to check it, but from the terminal, how do you
how do I know where is it publishing to? How?
Yeah, like it's publishing to a topic, right?
It's publishing to a topic.
How do you know the topic? So how do you know the topic is publishing to from the terminal?
I mean, I could show it now, or we could wait to when we get there.
Either one works on me.
Then we'll wait to when we get there. So, that's what he's asking. is. So look, this is why I prefer to do things. Yes, I what's up? Sorry, yeah, talk to them.
Just a small issue. For my terminal shell, I'm using ZSH. I switch from Bash to ZSH. But when I'm trying to run this package now, I don't know. It's not saying ROS2 as a command. Is it because I'm using ZSH and not Bash?
I have a question. How do you just switch terminals?
No, I did that quite some time ago. Like it's been sometimes since I switched to ZSH.
Are you on a native Ubuntu?
Yes.
I don't mean a dual boot, like a native Ubuntu, like full Ubuntu.
No, it's a dual boot.
A dual boot. For some reasons, you switched from Bash to ZSH, right?
Yes.
I'm more curious why, but let's assume you had good reasons to do that. Now, for the Bash, did you ever use ROS in Bash?
Yes, I used ROS in the Bash before I switched.
There's something you do. You probably put source. You've sourced it and you put it in Bash RC, right?
Okay. Let me source the environment first, Abby.
Yeah. So I'm most likely when you're installing, you sourced it into the Bash RC. So you have to source it into ZH RC. So that's just,
I think I just switch back to Bash. Is there a way to do that?
No. Now you switch ammo, you go leave on like that. You go use on like that. There's a way. There's a way to switch. Like it's like they give you, the power of Bash. I mean, okay, fine. It's any other terminal can do almost the same thing, but like there's this. It's just Bash, bro. So I can help you switch back. But if I'm to help you switch back, you have to explain why you switched to Z. I'm curious. I also want to learn what made you.
Like it's been some time since I switched to this ZSH. I was saying Bash normally.
I know well, that's not in dispute. Why did you switch?
I can't recall. I think it was because I saw a video on YouTube and then they were like, ZSH gives like it's better autocomplete when using the terminal. I think it was because of that.
Yeah, you can switch back. It's not a big deal. You can always switch back. Oh, Garrett is. Anyways, yeah, we can switch back. Just source it again. It should work the same way. I think even Mac. I think they're on. I've forgotten what terminal processor they use. Either it's ZH or something. So it should work. Anyways, as I was saying, in response to Prudence that asked for something a little bit advanced, the way I do things, I try as much as possible to carry anybody. So like, regardless of what this thing you have, right? So I'm trying to like build these things up. So there are sometimes I make explanations and I leave some details out, and someone that really, really knows it is like, oh no, that's not completely correct. Yeah, it's not completely correct, but that's the best way to pick people up, to make them know that, okay, yeah, everybody's following. Because like the true test of knowing something is not in overwhelming the next person, but like making the person actually understand. Like you can take a baby from scratch, and yeah. So that's why so either ways, we're going to do that later. Right, so you get, and I don't want to like confuse anybody. Okay, so what was I saying? Now we're publishing. Where are we at now, Seth? We are at 400 and something, roughly. Good. So we're publishing. Let us now listen, right? Subscribe. So ROS2 run demo node. Now, as you can see, everything lives in the demo node. It's still a package in a demo node, and it's called listener. Now, don't think it's called listener because it listens. You can name this talker, and if the logic is to listen, it will still listen. So the name is just for us to understand. The computer has no idea that this is the listener. It's just running the logic. And if you run the listener, something happens. We start hearing from 488. That's where we start hearing from. So all these many things that you were saying, no concern no more. Is when you actually start listening that he starts hearing it. So you can just leave this running for a while, look at it, stare at it, enjoy it. You can leave it side by side. It's almost real time. You see 57, you see 30, like it's almost in real time. You might think it's real time, but why I know it's not real time? It's not as if, even me, the first time I looked at it, I saw that it was real time. But later on, you see that the timestamps, there are slight difference in this, in fact, very slight difference in the timestamp. So it's, yeah. So that's the thing. So we are going to look at better examples and like, but for now, understand what's going on. You know, just build the knowledge on it. So how do I activate ROS in Ubuntu? Tracy, have you installed ROS? Okay. Now, when you try to run, what did you get? Like when you try to run the ROS2 run demo, what did you get? You haven't done anything. I mean, because why I'm asking is because you probably during your installation will probably have already sourced ROS into the bash file. So there might be no need to activate again. I'm on Justin. What's Justin Ubuntu? But now every day I learn something. What's Justin Ubuntu? Oh, just on it's okay. Just on Ubuntu. Great. It's showing ROS2 command not found. Clever. Good. So this is what you do. What do? You do source. You source opt. After opt, what do we even do, Seth? Opt ROS humble. Assuming you're on humble, setup dot bash. And all things being equal. So that's how to, for anybody that is showing ROS2 command not found, just source it. After you source it, if it works, then you can add it to a bash. But I'm just saying add it to the bash because I mean I'm supposed to show you how to add to the bash. Demo not found. Sudo apt install demo There's a procedure for that. Let me see. Just hold on. For anybody that shows demo not found and ROS2 not found. They are two different things. For the ROS2 you source, for the demo not found you like install the ROS package. So where do I? No, we're not running the code though. If you notice, you see what I said was don't run the code, just follow along. But majority of us decided to run the code, like not majority, but like good number of people decided to run the code. So we're just moving on that pace. I mean, I understand that some people only like follow up when they're like doing something. So, but they're not going to drag us back that much though. I'm looking at time. Demo node package ROS2 demo node package ROS2 demo node that. I mean, I know it's usually from sudo. Yeah, CPP. Oh, he wrote CCP. It's CPP. Probably that's why it's not found. But I mean, in case you still don't find it, you can actually install it separately. But first correct the spelling. I found it sudo apt install, the sudo apt install ROS demo nodes, But I trying to be boss again now, Queen. What have I done? Emmanuel, are you on Jazzy or you're on Humble? What ROS version are you on? You're on Humble. No worry, we'll debug your problem later. I'm not debugging anything now. Let's go back to what we're doing. Okay. Back to what we're doing. So this guy is just going to run. There's no harm. All right. Now, next thing. ROS2 topic lists. For prudence, this is what you type if you want to see what they are saying in where they are publishing it to. As you can see, you topic and then you list it, detach the terminal. Then let's see what is going on. Okay, ROS2 topic list. And now we have things. We have chatter, we have parameter, we have ROS out. Again, we do not know which one, right? I mean, I know it's chatter because I know it's chatter, but there are 3 topics. You don't know what's going on. So how do you now know for sure? And then that's when you now do ROS2 topic. Now you select the topic and then you echo into it. Echo, and then it's chatter. And now they're telling me show possibilities. Yes, I will. There's a lot of possibilities. Oh, sorry. The terminal lagged. Clear. ROS2 topic echo chatter. Good. And now we can see. Now again, it didn't start from number 1. No. It started from where we stopped or where it met the whole program running. So now we're on 7.8. It's on 7.8, 7.9. So everything, this is the real-time stuff like I was trying to tell you guys at the beginning that ROS2 enables that real time. So everything, at least to the human observer, is running in real time. 94, 94, 94, 95, 95, super fast, super nice. So that's how we roll. Okay, so there are some little talks that happens underneath what's happening here. I mean, you can all read this on your free time. Any question, just drop something for me. Good. Now let's list the nodes. There are other things we can list too. We can list nodes. If you notice, I'm just starting new terminals because there is a proper tool for this. There is a proper tool for this called Terminator. On Terminator, you can split terminals. I don't know if you just saw what I did on Terminator. I think Control-Shift-E splits it more. Control-Shift. What other Control-Shift again? Sorry, I've forgotten how the Control-Shift to. I think there's a way to do manually. Aha. So you can see you can split the terminals as much as you want. You can split anything. So this is a very, very nice tool if you want your life to be organized. But I mean, you see how nice it is. So you can just organize your terminals and everything. But no, I don't choose that. I choose to scatter everything everywhere and start looking for the terminals. So I'll create a new terminal. if I'm working and I need to be fast, I actually use the other terminal because it's easier to just split everything and not have to look for terminals everywhere. And then another thing is you might forget not all terminals on your lap. I mean, when you start working on like bigger projects, you quickly realize that not all terminals on your laptop are for your laptop. You can open the terminal inside the robot. You can open the terminal on the cloud. You can open the terminal anywhere. So like at times you can have like 7 to 9, 10 terminals, and then some of them are not even for your laptop. And then you forget, and then you put commands where they're not. It's usually messy. It's usually very, very messy. So I have this now. What do I want to do? ROS2. I think node lists or list node. Okay, so there are only 2 nodes running. You realize that it's only listener and talker that is showing, regardless of the fact that we have this guy here. Because this is not a node. We are just viewing what's going on inside, right? But the only 2 nodes are listeners and talker. So these are things that you should also, if you kill one node, say I kill the listener. If I kill the listener and I run this again, it doesn't see the listener. Then you can run the listener again, then it runs. So that's the drill. Yeah, shift O for horizontal. Yeah. Person with Sabi. See, Bash is the best. Said, Bash is the best. Let me quickly browse something. Is Bash? Is Bash? How do I? Yeah, Queen, what's up?
A lot of things are up. I cannot. My Ubuntu is.
I'm not resolving an error. Nicole. Is Bash owned by? Like, I don't know how to put this. Was Bash written in Linux? Bash is an interpret developed by. I think Linux will try. Okay, I'm coming. ZH. I think ZH or ZS or some ZHS. Nah, blah. This one, yeah, see, exactly. I knew it was for Mac. It has become the default shell for Mac OS. Why would you use ZH? Use Linux products. Okay. Oh, you are deceived. Exactly. See, forever. I would forever hit on Mac. But do not stress my leg. Sorry, hold on. Okay, good. Okay, ChatGPT. No, where is it? Okay, good. So, service. I don't think we have any service running, but we can still see what comes up. Okay, there are a couple of services running. This is these services are, how do I put it? They are tied to the nodes that are up, and they do some other different things, but let's not just go into that now. Okay, so I wanted to like paint a little picture about or with a robot arm, because we've been working on robot arms so far. So these are things you just know theoretically, because I mean would look at it, some of it, probably not all, but we'll look at some of it and then you see how it works, and then you can just extend the knowledge when you have that time. So joint publisher, it reads angles from encoder. This is the node, this is the topic. Topics communicates on joint states the same way our talker node communicates on chatter trajectory planning communicates on trajectory command. Motor controller converts the command, the actual commands, to motor torque. It still communicates on the motor command topic. We have the grip service, and basically these are some of the things. Trajectory planning is something that we are not going to touch. Well, I mean, if there are people interested in that, probably after the whole training, after everything is done, we can see if people want to learn that, because that's another thing entirely. Okay. For the sake of simplicity, I decided to end the class somehow early so I digest things. But this is the first task that I am going to. This is clapping. There are actually like 10 slides after this, right? So this task, I'm going to run through these tasks with you, like on the call, because it's not difficult, right? And it's not as if I don't think you guys can do it. It's more like you might run into a lot of frustrating things, and it's good to just see a video that you can reference. So okay, we'll start learning. Okay. So let me use a fresh. This is how you're going to do it exactly. If you have a folder for the training, whatever folder that is, I think I've even created one already. You have a folder for the training. Where'd I go? Okay, training. Okay, and then you, in this training now, again, you can do so many of all these things with the command line. Sorry, with the GUI. You can create a new folder on GUI. You can do everything on GUI. But I mean, the terminal is where you have power and where everything happens. So learn to use the terminal. So we are on the terminal now. And what I want to do is very simple. Most of the approach to learning ROS, you try to learn ROS like a lot. I think that's I can't say all, but a lot, because like I had to like watch different one. And what they try to do is they try to like make you program nodes. You write the nodes yourself and like they work you up that way. But I want to first use an already existing set of packages. So you see how those packages actually work. You actually see what these nodes actually do. So when given the chance to actually write yours, it's a bit easier and a bit comprehensible, because it's a bit difficult staring at a line in a C++ or a Python node. Even that, you see that hello chatter, that's hello world. It's easily about 20 something lines or more, 30 something lines. And while it is simple, relatively simple, the concepts embedded in it are a bit overwhelming for straight up beginners. That's why it's really difficult to just head on ROS, because they throw you, at least now you can see on a higher level what the nodes do, how they interact with each other. But like they throw you directly on the coding, because many people believe now the coding be the stuff, and then they throw you in the coding, and then you have to walk away from the coding up, and that is just stressful on a lot of people's brain. I mean, there are people that can function like that, but it's not just ideal. So when you're training, we're going to create a new space. Now I'm just doing ls, so you see that there's nothing in the directory. It's a blank folder, and then we're going to make a directory. What p does is p just says like parents. I have to edit this, if not it's going to make the directory in your home. And I don't want that in your home. So we make a directory, and then I'm coming to do this on the call. Okay, I take that out, and then we go back into the sharing. Can I tell you what it is? I really uncle. Now I am bigger, but Ferracalamo. Okay. And then we've made a directory. If I do ls now, we see the directory here. And then the next thing is we change directory into that directory we created. Then we have it there. So just those two commands. The next thing we do is, there's a reason why I was hell-bent on teaching people Git. And I asked many people say whether they can dodge Git. Okay, no wala. You have to know Git. Because now we're using Git. We're using Git. We always use Git. Git's clone branch. I spoke about branch one certain time. Okay. And now we are seeing depth. All right. I don't think this is wise to type. I mean, I could have just copied it, but I've already started typing. I think there's enough time for me to actually go back and copy this thing. But this, I think, sunken costs. I don't know what psychologists call it, where you've already invested some time in something and you don't want to waste that time you invested in it. Source to control demos. Okay. Assuming I didn't make any mistake, this should work. Okay, so cloned it, and I cloned it into source. Now, something we should also know is that, but I think this one experience will teach you. There are 4 folders technically, but all your code goes into source. Anytime you build the package, now what is building of package? So many terminologies now. When you write your script, you don't just run the script with ROS. You have to do ROS run, and then that package, and then but like we haven't made the package. You have to first make the package. Let me just send you over so you see what I'm saying. If we go to, now this is what I mean. If everything was organized, I would know where everything is. So ROS run demo, this is the package. So we have to actually get the package. In order to get the package, the only thing we have is source. The only thing we have is source. So to get the package, we build. In order to build from source, call con build. Call con build. And it's building. What is it building? It's building this ROS project that we already got. So it's going to take a while, build a lot of it. We are not writing our ROS project from start. In this case, we are getting an already written one, which is like a demo, which we use to like strip things down and understand. So we understand things faster. And now we have built it, everything built successfully on my own side, because there are a lot of things that you have to do for building. But then when you do it on your own, you're going to have an error. You're actually going to have an error, and that's the fun part. I've been waiting with the depth. Now, yeah, sunk fallacy. Yeah, sunk fallacy. Knowledge gap. Because of philosophy or psychology, you're not even serious. See, plenty error day, and that's where things become fun actually. So Sai said, I beg, what's depth? What does depth do? You need to know how Git actually works. But I don't make a research. See, make error. Clever. I'm so happy. See, like, I'm happy when things break and I know they are supposed to break. So like, it's supposed to break. That's why I have this slide. Where's the slide? That's why I have this slide. By now, you should have some errors, and I love the journey actually. Okay, so now you've seen CMake. At least I appreciate you for taking time to read the terminal. I honestly appreciate you because now you know at least something is CMake and there's something wrong with CMake. Now, moving on. I mean, yeah, you have to appreciate me for looking for that sticker. I mean, I put a lot of effort into playing. Okay, now this explanation is for what we are doing. Something broke, and for me to explain what broke, I want to really take you guys on the journey on what's happening behind the scene, so you actually know why that thing broke. So this is how the story goes. Remember, the first thing I said you do is make a directory. That directory is ROS2 class 1 WS. WS means workspace. Now remember I said ROS allows us to integrate so many robotic components, and like you can use it in different places. A framework that like the whole world, or at least majority of the whole robotic world is using. You can imagine how big it's going to be. You see, even when you guys were installing ROS, some people installed ROS for like an hour or two. Things were just running down the screen. How did you say it? So like, ROS is that very big workshop. But for you to work in ROS, you need to create your own personal space. That is what we call workspace. So on that workspace, you write your little packages, you write everything. And then if you ever call a package, ROS will first of all check your workspace if you have that package before it goes into the main big ROS that you installed. So understand, it's going to check your area first before it goes into the big area. Let's proceed on something now. Now, when I say this, make directory, we make the directory is a new folder. Now, our workspace is that new folder, ROS2 class 1 WS. That's the workspace. That folder is the cage, the isolation. Then we create a source, make directory P. It creates the parent and the source. Please, it's basically Linux stuff. Everybody is, regardless of if you're using a Windows PC, if you're on WSL, that is a Linux or a Linux environment. So these things would work as it is. So now, everything here is straightforward. We're just creating the workspace and then changing directory into the workspace. So we've created it, we move into that workspace. And now, we now clone what we want to use. You're asking me for depth. See depth here. But this is like a simplification. Somebody tried to clone the repo, the repo that you guys did notable mention. Somebody tried to clone that repo some days ago, and I was very happy when he faced a very common challenge. The repository now is nearly 1 gig. It's not as if it's really 1 gig that's on that repo. The content of the repo might not be up to 1 gig, but all of you have sent in pull requests, and there's a lot of activity there. The Git itself has to keep track of all these things. There's something people, and it's building. So technically, you are cloning both the content of the repository and its history, and that's some big ass history. Try and clone Pilot, and if you don't have good network, you would get frustrated. Even me, I was frustrated when I was trying to clone that repository. So many people have contributed, and it's not really all that big. So that's how I now found out that, oh, so you didn't do the assignment since, and now you want to do the assignment. That's besides the point. If you had cloned it initially, fetching would have been, or pulling would have been a more easier task, and then something like that. But it's how it is. So depth 1 just tells us, just grab the latest copy. No need to pull the whole history. It downloads faster. We don't really need everything, actually. We don't. So, is there anything, Jai? Yes, 3 hours. It took 3 hours to make that stuff. Samuel, I'm coming to your CMake error. Maybe by now you must have found out how to solve it, but either ways, I want to build things slowly so I don't jump into it. Okay, so now this is the git clone branch humble. You can change this to Jazzy if you're on Jazzy, or Ion for some reasons. depth 1, HTTPS, this is the repository that holds the package you want to play with, and then source ROS2 control demos. This is where we want to put it. So I will tell you something. You can see I have source. You can see source here. If I go into the source, I have ROS control demos. So basically, I extracted everything into ROS control demos. So all things being equal, you are supposed to now proceed to build, because you've gotten the package and you want to build. But welcome to something that is called dependencies. Dependencies are when you say build, you are telling the computer to everything in that your workspace, put it together, stack it up, link everything up, so that we can have a package or a project that we can call the package and then call the node, put up everything up together. But let's assume one of your robots, you need like a 4mm link key to couple it. Physically, you won't be able to do it until you get that Allen key. That's just the thing. If you need a screwdriver, you can't use your hand to screw the nut in. Like, you can't use your hand to screw the screw nut in. Like, it's not going to just work. So you have to actually import those things you need. That's dependencies. Everybody know what dependencies from programming. And then the same thing also like plagues us here in ROS. Now, the CMake you got is this issue. Samuel that got CMake, ROS control CMake is missing. It's either it's missing or it's misconfigured. That's the two errors you get. Missing or misconfigured, there is a quick fix. Some people might have ROS2 control missing. Some might have ROS2 controller, different things missing, because you have not installed these things yet. And the demo project you are trying to use, make use of all these things. So you have to get them. How do you go about that? The solution is simple. Sudo apt install ROS Humble or ROS Jazzy ROS2 controller, ROS Humble or Jazzy or Ion or Foxy, ROS2 controllers, ROS Humble. You basically install everything. So me, I have already done this. That's why it worked for me. I have already done this, so it worked for me. So, I mean, you're going to actually feel a couple of hits. But now, let me now show you the reason why I did this, right? We now have this ls. All right, good. So I want to run this. Where did I get this command from? This command is not really part of the task. The task is at least just build that. If you can build it, then I will tell you what to do from there on. So this is what I want to show you. ROS2 launch. Now, we didn't talk about launch because launch is like a step above run. Like, launch is a bit different. So ROS2 launch, this. What's going on? Mommy, oh. Da. ls cd ls cd ROS ls source install setup.bash. Okay, and run this now. I don't know if you people are familiar with something like this. This is a little of that robotic arm we did. If you put it directly here, you have the 2D. And then we have this, whereby if I take this, it goes like this. If I take this, it goes like this. So for those people that did the first assignment, you quickly grab what might be going on behind the scene. It's no more learning. It's more like poetry. Because like you're moving it, but then deep down, you know why it's moving, you know how it's moving, you know the math behind it, you know the actual codes behind it. Like I can show you something real quick that just came to my mind. Let me open a new terminal, or let me go to the folder where this is. I can open the source. I can open in terminal code. I have my VS code open. Yes, trust. So this is my VS code. What are we running? We are running ROS2 control demo example one. Example one, that's what we are running. So example one, the launch will be in bring up. The launch should be here. Robot launch. Okay, so these are his launch. Hold on. I'm trying to get something. Okay, this is the first launch. I mean, we're going to actually go over all this, but there's something I am looking for. Like, I am pretty sure I should see it. I'm pretty sure I should see it. Pretty sure I should see it somewhere here. All right. So, like, under the hood, let me show you something. I'll just show you something, like some things would add up. We are running this ROS launch, and remember I told you, whatever you see here is the node. The node that is running is robot state publisher, and it's publishing what angles, like it's constantly publishing the angles, right? And then in here, we can see something that I think some of us must have seen in the previous classes: transform, translation, transform, rotation. Basically, even as ROS as a whole, what happens is still the same thing that we do. We look at things here. This is like a header file for the transform. This is another. Now we see more definitions of vectors. Remember I said one of the best ways of doing that whole transformation maths instead of using geometry is like with vectors. So we actually see those things. We see those matrices that we see definitions of matrices and how they actually work, at least on the lower end. So my point is, this is similar to the exercise we did. It's similar with the exercise we did, and you can do your forward kinematics. This actually computes forward kinematics for you. So this is just like an introduction to ROS. Your small window is blocking some of the text. I mean, you didn't actually see what I was showing. That's sad. Okay, so basically, I'll just want you guys to go over the tags. there's going to be a lot of issues because errors and things that we're going to solve. Then when you are done with it, let me put this command that I wrote. Let me put the command. If from the north, if from the Canada, and go solo. Okay. So let's assume we get everything done. Source in hash text this Roberto. Okay, this is like the final thing you do in order to bring up that this visualization that we know of with the slider and everything. Okay, so what next would we actually look at? This class is just to like show you guys the ropes. We would now have to look at proper things. And by proper things, I mean URDFs. I didn't say anything about URDFs. We'll look at things like that. Then we'll now look at how to build an actual robotic arm. Something similar. The reason being that this one it's like a makeshift. It just the links, the joints, it's good enough to do a couple of simulations and stuff, but no robotic arm actually looks like this in real life. So we do that, and then we add controls, we use move it, some little things that we can apply in real life. So ROS is not just a software, it actually isn't an operating system either. It's just a mode of communication and collaboration to actually keep things easy in robotics. So do we have questions? Do we have any contribution or anything? No, the recording day. There was something you asked us to research about when I first started. I've forgotten what I said you research. That's why I say you should keep a note or something nearby. I don't know what I said you should research. It just came to my head and I just said it. So if anybody got that, probably help him out. So yeah, our next class is supposed to be Thursday, right? It's supposed to be Thursday. I want it to be Friday so that I would have enough time to fix people that have issues. Because our next class, we are going to actually run a couple of things, and I would want everybody to be on the same wavelength, at least have the system up and running. So, something about golf. Okay, it's a golf trolley powered by ROS2, and they raised 700K. That's a lot of money, actually. That's a lot of money. We spend it on occasions. Was it euros or pounds? I think it was 700 euros or pounds. Botronics. I think you guys will know him. Yeah, that's so basically the class is over. I think in the group I was saying that there's some things that I did over the weekend, like some actual work, in case anybody actually cares for a story or something, like to share that bomb. Yeah. All right, the recordings will be up very shortly.